Welcome to the series of data structures. So in this series, the next topic we are going to learn that is algorithms. My name is Professor Pratap Mohite. What is algorithm? An algorithm is a procedure having well-defined steps for solving a particular problem. Algorithm is finite set of logic or instructions written in order to accomplish the certain predefined task. It is not the complete program or a code. It is just a solution, that is logic of a program, which can be represented either as an information description using the flowchart or pseudocode. There are more number of categories of algorithm. The categories of algorithm: sort. Algorithm developed for sorting the items in certain order. Search. Algorithm developed for searching the items inside the data structure. Delete. Algorithm developed for deleting the existing element from the data structure. Insert. Algorithm developed for inserting an element inside a data structure. And update. Algorithm developed for updating the existing element inside a data structure. The performance of algorithm is measured on the basis of following properties. The first is the time complexity and second is the space complexity. So what is a time complexity? In computer science, the time complexity is the computational complexity that describes the amount of time it takes to run an algorithm. The time complexity is commonly estimated by counting the number of elementary operations performed by the algorithm, supposing that each elementary operation takes a fixed amount of time to perform. Thus, the amount of time taken and the number of elementary operations performed by the algorithm are taken to differ by at most a constant factor. Since an algorithm's running time may vary among different inputs of the same size, one commonly considers the worst case complexity, which is the maximum amount of time required for an input of a given size. Less common and usually specified explicitly is the average case complexity, which is the average of the time taken on inputs of a given size. So this makes sense because there are only a finite number of possible inputs of a given size. In both cases, the time complexity is generally expressed as a function of size of the input. Second is the space complexity. The space complexity of an algorithm or a computer program is the amount of memory space required to solve an instant of the computational problem as a function of characteristics of the input. It is the memory required by an algorithm to execute a program and produce output. Each algorithm must have specification, that the description of computational procedure. Second, precondition, the conditions on input. Body of the algorithm, a sequence of clear and unambiguous instructions. Post condition, the conditions on output. An algorithm to multiply the two numbers x and y and display the result in z. So step 1, we have to start. Step 2, declare three integers, that is x, y and z. Step 3, define values of x and y. Step 4, multiply values of x and y. Step 5, store the output of step 4 in z. Step 6, print z. Step 7, stop. Characteristics of an algorithm. First characteristic is input. An algorithm must have zero or well-defined inputs. Output. An algorithm must have one or well-defined outputs and should match with the desired output. Feasibility. An algorithm must be terminated after the finite number of steps. Independent. An algorithm must have step-by-step directions which is independent of any programming code. Unambiguous. An algorithm must be unambiguous and clear. Each of their step and input and outputs must be clear and lead to only one meaning. Next important topic is the flowcharts. A flowchart is a type of diagram that represents an algorithm, workflow or process. The The flowchart shows the steps as boxes of various kind and they are ordered by connecting the boxes with the arrows. So this diagrammatic representation illustrates a solution model to a given problem. Flowcharts are used in analyzing, designing, documenting or managing the process or program in various fields. Flow lines. The default flow is left to right and top to bottom, the same way you read the English. To save time, arrowheads are often only drawn when the flow lines go contrary to the normal. Simple flowcharting symbols, that is terminal. The rounded rectangle or terminal point indicates the flowchart's starting and ending point. So this is the symbol that is used as a terminal. Input or output. The parallelograms designate input or output operations. So this symbol shows the input or output. Next is the process. The rectangle depicts a process such as a mathematical computational or a variable assignment. That's a rectangle is used as a process. Decision. The diamond is used to represent the true or false statement being tested in a decision symbol. So here, this is the simple example of how we can draw a flowchart by using the symbols. Our aim is we have to draw a flowchart for addition of two numbers entered by the user. This is second flowchart that we have used to find the largest among three different numbers entered by the user.